In this example, we're going to mix together a couple of things from in the chapter. Really what we're looking at here is both a function template, or a template function rather, and an overloaded template function. So, what are the smaller bits of that? The smaller bits of this are as follows. We have here two template functions. They are denoted by the word, you guessed it, template. And here within our operators class T, that is just what we are calling this. So from here on out, when we refer to T, this is going to be our class name, and it is always, or is also rather here, it is cold down here, and I am at the end of how much cold I can take. And here T stands, it's here for type. So it's not similar to what we had seen in other examples of how it was that we created a structure, or how it was that we created a class, or how it is even that we create simpler things like arrays or vectors to be able to work with. But the fantastic thing here again about the template is that we don't have to specify what kinds of data are being passed. All we have to tell C++ how to do is something with it, and it will generate, C++ at the time of run will generate what it needs to do to actually make this function work. So here we've got the sum of as what our function is doing, value plus value, but we're also overloading it. We've got value plus value, and our second sum function of our template type is going to be when we pass along 3 arguments for the parameters here. So really, what are we talking about? Here you can see that in my main on line 18, I have a series of doubles declared, num1, num2, num3, because I'm going to need as many as 3 numbers to pass along to my template function. I can enter 2 values, I can enter 3 values, and C++ is, at the time of run, going to know which of the 2 of these to call based on its number of arguments. So I'm just going to enter 2 values. Now, I'm going to enter 2 double values because that's what my program is expecting, right? I'm expecting doubles to be passed here because that's what I have it declared as on line 18. So I'm going to say 2.2 and 3.3, and their sum is 5.5. For everybody with a grade school familiarity, that in fact is true. So next I'm going to say 10, I'm going to say 20, and I'm going to say 30. Now, hold on. What is the result that you expect from this? 10 plus 20 plus 30 equals 60. But these are doubles that I am passing along to my template function. So if I am passing doubles along, I should expect to see the result of calling my template function being a double return. However, what I see is an integer, and that's because these are untyped. When these are passed to the template functions, first and foremost, C++ has to figure out how many arguments are you passing. You'll notice that the parameters on that list are of type, type, type. C++ has to figure out what to do with these. So it's going to look at the values you've entered. 10, 20, 30, those are not 10.0, 20.0, and 30.0. So these, the runtime figures, have got to be integers instead. So if we do this the other way around, we'll prove that it doesn't really matter. The typing here in the template class, or the function rather, is all that matters because C++ is doing the job to figure out what is going on. So the first time around, I said with decimals what those values are, so 2 and 3, and I'm going to get their sum is 5 instead of 5.5. This time around, I'm going to say 10.1, 20.2 and 30.3, and I get 60.6. So again, it is because of the arguments that are being passed. That is what C++ is going to use to determine their type, to determine what sort of function this template is going to have. And it doesn't matter the order of operations in which we enter them in here. It's up to C++ at runtime which of those types to use. So here you can see is our set up for a template function. Next, we're going to look at a template class.